do it. You're taking a simple system and making it hard. You're taking something super simple and making it hard. You understand what I'm saying? You're taking something simple and making it complex. That's your thing. Stop it. Okay. So your colored pen should be up. That's not optional. That is required. If you still can't figure that out, then make a change. Do something different. Let's have, I'll make the change afterwards. All right, number one, what did we get? We'll start with Danielle, Marlon, and then we'll go to Kiara. What'd you get? Okay?
We got 0 and -3.
Okay?
1.
Okay, so we have a massive disagreement. DeAndre and then Cameron.
I got no solution.
Okay?
No solution.
It is no solution. Number two, what did you get? We'll start with Raquel, Essence, and then we'll go to, let's see. Number 5. Number 5. Okay, go ahead. I couldn't hear you. Okay. Okay, so we have a disagreement again. Anyone else? Marlon, what did you think?
No solution.
No solution? It is, that's supposed to say 1 and 3. The answers are 1 and 3. So let's back up for a second. And so let's look at number 1. And could someone tell us what the first step was? What was the first step? We got 4 people who know. We need to move like that. Selena. Well, you kind of said it in a backwards kind of way. You added. You said isolate the stuff outside the absolute value? We're not going to use the word thingy and we're not going to point. We're going to actually speak using words. If you don't know the words, then look back in your notes and get the words. But one way or another, if you're sitting in this room, you're going to do this, and there's no option. Everybody, those of you who are huddled down like this because you're afraid, that's fine. That feeling of being afraid is because you're not prepared. Okay? Andrew? Subtract 4 from both sides. Subtract 4, subtract 4. what Selena was trying to say was isolate the absolute value. You have to say the word isolate and you have to say absolute value. If you don't know how to say that, go home and practice in front of a mirror. One way or another, come to this room prepared. So, this cancels out and we get the absolute value isolated. We spent most of the lesson last time working on that. What do we get on the right-hand side? Page? -1. Now, the answer was no solution, so I'm going to explain why. Why was it no solution, Beyonce? Well, the answer is in negative, but this number on the right-hand side is negative, so what? Why not? Why not? Sam's going to answer in a second, but hold on for a second. Well, could I solve this? Could we solve that? Yeah, we can solve that. But we can't solve that. We can solve this, but we can't solve that. Sam, tell us why.
Because absolute value is always positive.
Why? Absolute value is always positive. That was great. Why? Every single person in the room should know. Danae? Because it's a distance. And distance cannot be negative. There's no such thing. Distance is always positive. So Sam was right and Danae was right, but you have to be able to know that and explain it. Okay? So, at this point, when you see this, you should have stopped. Because distance, and that's what this says, the distance equals -1, then you should have said, oh yeah, I remember because I've been working hard. Distance can't be negative, so that's no solution. Any questions? Any questions about that? Okay. Number 2 was a challenge question. We didn't see anything like it. But if you just followed along, then you would have been able to get the answer. Let's review this path that we took. We started with one-step equations, and then we learned how to do two-step equations. And then from two-step equations, we did multi-step equations. From multi-step equations, we did equations with variables on both sides. And then from there, we did solving formulas for a variable, and now we're here. So everything that you've learned already applies to everything that comes after it. So, follow the steps. What's step 1? Go ahead, Caesar. What was step 1? I know you had done it.
Step 1 is you don't have to do it this way. It's already isolated.
It's already isolated. Beautiful. So this is where we come to case 1 and case 2. I was very impressed with many of my students who continued to write case 1 and case 2. That actually turns out to be a very helpful thing to do. So now when we go to case 1 and case 2, here's where a bunch of you messed up. We drop the absolute value. That's the whole point. This is a trick to getting the solution. So we write this whole equation without the absolute value. 3 minus 2x equals x. No absolute value. What about case number 2? What's the difference between case 2 and case 1? There was one detail that's different. Everybody in the room should know. Julian? Very good. We just flip the sign of whatever's on the right-hand side. So it's 3 minus 2x equals -x. Solve the equations. That's it. Solve. You know how to do this. Let me talk about the path again. You did one-step equations, then you did two-step equations, then you did multi-step equations, then you did multi-step equations with variables on both sides. Variables on both sides, that's it. You already know how to do it. So we have -2x, and we have an x. What do we do first? Raquel? said that beautifully. Add 2x to both sides. This cancels out, and look at this. 3 equals 3x. Julia? Where did I get the what? The 3 right here?
No.
Well, what's 1x plus 2x? 3x. 1x plus 2x is 3x. It's a good question, Juliana, because half the class was wondering the same thing. You were the only one brave enough to ask. So now it's a simple solve. It's a one-step equation. 3 times what number is 3? 1. X equals 1. Solve the other side. One thing you learned last time is that the steps for case 2 are going to be the same as step 1. So we already know what to do. I don't have to rethink it. Add 2x to both sides. The difference is going to be that the result won't be the same. 2x and a negative 1x is just x. And so there are two solutions, x equals 1 and x equals 3. Comments, questions, concerns? Okay? Okay, so we continue building on everything we've learned. So everything you have learned so far this year is going to apply today. We're going to use those ideas to build an understanding of ratios, rates, and solving proportions. Most of our time will be spent solving proportions. To do that, we need a basic understanding of what a proportion is, and it comes from this idea of a ratio. A ratio is a comparison of two values by division. So in the world of note-taking, you could have summed up that entire sentence probably in 3 or 4 words. The ratio can be written as this, this, or this. But we will spend most of our time writing ratios like this, which looks just like a fraction. Ratios that are the same are called equivalent. Equivalent is a fancy word that means the same value. So that's the basic idea. From there we build to something called a rate. A rate is a ratio. So a rate is a type of ratio, but the difference between them is that a rate has different units of measurement. A ratio will often just be a number and then another number. A rate will have units of measurement. So for example, 34 miles to 2 gallons is a ratio, but we call it a rate because of the units of measurement. Most often, rates are written as what is called a unit rate. And a unit rate is a rate written with 1 as the denominator. And so we can take this rate and rewrite it as this. And this is actually an incredibly important idea just in our world, not even just in a classroom, but in our world. Because if you've ever seen a commercial for a car on TV, online, in a magazine, anywhere, they always put the mileage, the miles per gallon that the car can handle. And this is a selling point. This is just one example of why rates are important. So for example, I bought my car because it gets such fantastic gas mileage. So my car can get like 30 miles to the gallon. So 30 mpg. If you buy a Hummer, you get like 8 miles per gallon. And so the difference is, well, so what? So I'll just get more gas. Well, the problem is you have to pay for gas. And so the person who has the Hummer has to pay for gas much more often than I do. And so that was something valuable to me. Now, if someone doesn't care about money and just wants the Hummer because it's an awesome vehicle, great, that's fine. That's their choice. But if you're talking about value, then you're talking about which one gets the best mileage. The only way to compare them is if they're written as unit rates. That's what allows you to compare them. From ratios and rates, we develop the idea of a proportion. A proportion is an equality of two ratios. It's an equation. Here are three examples of proportions. So, this proportion is showing that these are equal ratios. We can prove that a whole bunch of different ways. I could simply take out a calculator and show you that they are equal to each other. 10 divided by 30 is 0.3 repeating. 1 divided by 3 is 0.3 repeating, so that's a proportion. This proportion here in the middle is slightly different because we have something missing. And that is more of a question. This is asking what number would have to go here to make this true. Does anyone know what number would have to go there to make it true? Kyle? How'd you figure that out? That's right. So 8 times 3 gives us 24. 5 times 3 would give us 15. So that's a quick way of solving a basic proportion. Here on the right, you have a literal equation with all variables, but it's still a proportion. Does anyone have any questions? So, trying to set you guys up for success, we have this in a couple of steps to solve a proportion. First, find the cross products. That may be a new phrase for you, it may not. We will demonstrate in a moment. Step 2, then solve the resulting equation. For the moment, I want to focus on step 1. So we're going to talk just about this with these two examples. So find the cross products, then solve the equation. Cross products. Anyone recall what it means to do? A couple people? 3 people? 4 people? Go ahead, Raquel. What is cross products to you? Sure.
You would do 5 times 24 divided by.
Okay, so that's a little shortcut, but see how it says cross products. So you said 5 times 24, that's one product. What's the other product? That's right. So you multiply both of them. So your technique will work. However, what are you going to do here? Not going to work. So this is what you are going to be doing. This is 7th grade math. Algebra 1 honors. 7th grade math. Today you will be doing this, but it is based on this. So Raquel was right, but we want to be able to do this at the higher level. So here's how you do it. Cross product means you're going to multiply from the top left down, and you're going to put the result right underneath. 5 times 24, well that's easy to do. 5 times 20 and 5 times 4, well that's easy, 120. And now do the other cross product, x times 8. X times 8 is 8x, and put the equal sign in between them. Find the cross products. We did that. Now, I'm not concerned about the equation yet, so we're just going to leave that alone. So that's the idea of a cross product. Now, we need to do it with a more complex example. Cross product. Top left to bottom right. 5x times 6. What's 5x times 6 going to turn out to be? Got a few people who know? Jamel? Well, we're multiplying, so does that sound right to you? So would you like to fix it? Yeah, it's 30x. So we write that right underneath 30x. So that's easy, because it's all multiplying. Here's where it's a little more complex. X minus 2 times 10. Does anyone know what that's going to look like when we write it down? It's going to look like something you've dealt with this year. Marlon?
10x minus 2.
Well, that's a good guess, but unfortunately that would be incorrect, and it's because you missed an idea that we touched on a couple of weeks ago. Briante?
X minus 3.
Well, again, that would also be wrong because you missed an idea, so forget about that. Let's write it out. So I don't want the answer, I want to write it out. Paige? And what is that an example of? That's distributive property. Because what you have to do is multiply the 10 times everything, not just times the first thing. And so this is 10 times x minus 2. That's distributive property. Now, distribute, and we can solve. But we're not going to do that yet. I'm just dealing with cross products. So all I need you to understand for the moment is cross product means you're multiplying diagonally. Top left to bottom right, top right to bottom left. So it forms an X in between. Do I expect to see arrows drawn? Absolutely. Every arrow means multiply, just like in distributive property. Any questions? Good, so now let's do some formal examples from beginning to end. So, Algebra 1 honors. Solve p over 15 to p plus 15 over 42 equals p minus 5 over 14. So, this is a complicated question. It's a complicated proportion. But it still requires the same techniques and process. Cross product first. So we're going to multiply the top left times the bottom right, and the result's going to go right underneath. And when I write it out, what is it going to be an example of? Marlon?
Distributive property.
Distributive property, beautifully said. So we're going to put the 14 times p plus 15. Don't worry about what the result will be, just write it out. That's the first thing to do. Now, the other cross product. This times this. What will that be an example of when we write it out? Sam?
Distributive property.
Distributive property, beautiful. I called on him out of the blue and he did not hesitate because he knows what he's doing and he's paying attention. So, we are done with the cross products. Now we solve the resulting equation. Well, guess what? You already know how to do everything because we already did questions like this. We did questions like this last week. All it is an equation with variable on both sides. What do we have to do to continue? What do we have to do to continue? Good, we have a bunch of people. 1, 2, 3, 4, 5, 6. Good, Jamel? Beautiful, you said it one word. Distribute, and then we're going to have to distribute over here. Beautiful. Can anyone tell me the result of the left already? What is the result going to be over here on the left? Kiara?
42p plus 210. Wait, oh, minus 210.
Minus 210, very good. What about on the right-hand side? What's the result going to be there? Jeanette?
210 plus 14p.
Good. 14p plus 210, and she can write it in the order that she put. That's fine. All we did was distribute. Beautiful job. Now it's an equation with variables on both sides. Still. What do we do next? Andrew?
Subtract 14p from both sides.
Beautifully said. Subtract 14p from both sides. This will disappear, and now we just have to subtract correctly. 42p minus 14p, 28p minus 210 equals 210. Anyone know how many steps we have left? You should. You should know exactly how many steps we have left. DeAndre?
2.
Yeah, it's a two-step equation, and your spidey sense should be going crazy. Because you should be like, I know how to do this, no problem. What's the next thing we do? Essence? Add 210 to both sides. That cancels out, and we get 28p equals 420. And what's the final step that we do? Kayla? Beautifully said. Divide both sides by 28. I ran out of room a little bit, but that cancels out, and we get p equals what? What is the final solution, Cameron? Cameron? 15. P equals 15. So that was a lot of work. It took us at least 5 minutes to do. But here's the interesting thing for today. See all of this? All of that? You already knew how to do all that. So there was only one new thing today, and that was doing this first. The rest, you already knew how to do. So it's about paying attention to details and knowing what you're allowed to do and what you're not allowed to do. Does anyone have any comments or questions about Part A? Okay. Part B. So again, you already know everything except for just this first step. Cross product, cross product. Let's see who's catching on. What do we get as a result of doing the first cross product, the 32 minus y times the 10? What do we get from that? 2 volunteers? 3? Go ahead, Paige. Very good. 10 times the quantity, 32 minus y. What about the other cross product? 6 times y. What do we get as a result there? Got a bunch of people already doing the whole thing? Okay, that's fine. Marla?
6y.
6y. Beautifully said. No big deal. What do we have to do now to solve the resulting equation, Caesar? Distribute. Distribute here. Distribute here. Every arrow means multiply. 6y hasn't been used yet. 10 times 32, that's easy for everyone in here, simple computation. And 10 times negative y is negative 10y. Again, it's just an equation with variables on both sides. So what do we do to solve it? Brianna? Add 10y to both sides. This disappears, and we get 16y equals 320. Well, that's actually easy, because if you just say, well, 16y equals 32, that you could figure out mentally, and then just add a 0 on the end. So what is y equal to in this equation? Rose? Very good. Y equals 20. Anyone have any comments, questions about Part B? Any questions about Part A or Part B? Now, I do not expect that you have mastered this, but I expect that you are starting to digest it. And so now you're going to attempt on your own. Checkpoint number 1. This is an individual activity. You got 2 minutes to solve this. Work hard, put in effort. That's my expectation. All right. What'd you get? 1, 2, 3, 4, 5, 6, 7. Oh, yeah, I got a whole bunch of confidence. We start with Kayla, Caesar, Paige, Rose. What'd you get? 2. Got 4 people who got a solution of 2. Z is 2. Give me a thumbs up if you got it correct. Okay, a lot of people got it correct, but some people did not. Comments or questions on this? Yes. What did you get? -9. Briante, what did you get? Okay. Let's make sure we copied it correctly. That's the first thing I'd like to get out of the way. So did you put a 108 here at the bottom? I saw a few people put something different. So we did a cross product here, and what did you get as a result? Very good, 108Z. And then we did the cross product over here, and what did you get as a result?
The parentheses and Z plus 7.
Good. And then what did you do next?
I did the whole thing backwards.
Okay, so you have this whole thing on the right and this whole thing on the left? Okay, but that's okay.
No. I put 108 right and then the parentheses Z plus 7.
Ah, so you unfortunately didn't do cross products, you did like straight something. Okay, good. Any other comments, questions? Did you find your mistake? Did you do this?
Yeah.
Did you distribute correctly? What was your result?
I got 3.
Right, but what is your result of distributive? Okay, well, don't erase. All right, I'll come look.
I know I did wrong. I put 4 times 24.
Okay. All right, any comments, questions? All right, example 2. Give me a thumbs up if this looks easier to you than the other question that we've done 3 other ones. Give me a thumbs up if this looks easier. Okay, some of you think it's easier? Good. Put your thumbs down. Yeah, in fact, you should look at this and think it's an absolute joke at this point. And some of these, if you use Kyle's method, you can figure out doing nothing. Kyle, can you look at this and tell me what the answer is? Yeah, it's 4. How'd you do it? That's right. So 28 divided by 7 is 4. So if we divide by 4 on the bottom, then we have to divide by 4 on the top. So 16 divided by 4 would be 4. You don't have to do anything. Now that won't always work. Sometimes you'll have something like this, and then you can't easily find what we divided by so that you could do it here. But it doesn't matter because we have another technique. Cross product. Cross product, cross product. But now it should look ridiculously easy. 20 times 28. That's either a calculator or mental math. Well, I can do 10 times 28 and then double it. That's easy. 560 equals 70b. It's a one-step equation. You could have done that on part A as well. Cross product, 28y equals 112. But the point is that this should be now incredibly easy for you because now you are starting to develop mastery of this. Does anyone have any questions about how to do this? Good. Now you try 2 on your own. Find the solutions to these 2. You got 2 questions, you got 2 minutes. Mental trick, or do you put a 0 in front of it? You should get used to that. It's going to be helpful later on. Yes. Part B. It's 2.5. All right. Let's see how we did with simple proportions. And I say simple, even though they used to be hard. Now they're simple for you. What do we get for part A? Good, more confidence. We'll start with Andrew, Sam, and then Kayla. Andrew. Okay. Okay. Okay, so we have some agreement, some disagreement. DeAndre, what'd you get for part A?
Part A got W equals 45.
Okay, more support for 45, Juliana? 45. The correct answer is 5. Part B was a little bit tougher. What'd you get for part B? We'll start with Marlon, Kyle, and then Essence, and if we need more help, we'll come up here. Who did I say? Go.
0.5.
Okay. So where you have agreement here? 0.08. So what did you think? So it seems to be more support for 0.5. Selena? So it comes out to 0.5. So, I mean, Raquel, what was your shortcut that you had talked about earlier?
12 times 2.5 divided by 60.
Yeah, when you have a simple proportion, you can multiply and then divide by that number and it will tell you the answer. It's a super quick thing to do. So you have your choice. You could have said, oh, 5 times 3 is 15, so multiply by 3. You unfortunately divided by 3, and that's why you got messed up. But you had the right idea. In this case, you would either have to do full cross product, and you end up with 60f equals, 2430. And then divide both sides by 60, or you could do Raquel's shortcut, which is multiply and then divide by that number, and you'll get 0.5 as well. So you got choices. Any comments or questions? So we have one more idea to go over, but I want to show you what we did today, and I did this on purpose. We did the most difficult question first. I only do this with advanced classes. Most difficult question first. Took us by far the longest. This one was also challenging, but not as challenging as the first one. This one was also challenging, but not as challenging as the first one, and we've worked our way backwards to easy ones. And we're going to continue doing that. But one of the things is it should now seem really easy to you. Okay? Any comments, questions before we go to the last idea of the day? Okay, so the last idea is the idea of a rate. You don't have to write this down. This is the same thing that I had at the beginning. A rate. So we're going to work with unit rates. So, you do not have to copy all of example 3 part A. You just need to read it. Read it to yourself. I mean, of course, right, example 3, part A, just read it. So I'm not 100% sure how to pronounce things in German, but I imagine his name is Ralph, either Lau or Lou, I'm not sure, from Germany, and he flipped a pancake. He broke the world record. He flipped a pancake 416 times in 120 seconds. What's the unit rate? In other words, how many times did the pancake flip in 1 second? So, I'm going to show you quickly the long way, which isn't very long, and then we're going to do the quick little shortcut. Unit rates are incredibly easy. First of all, you need to form a ratio out of the numbers. So we're going to put 416 flips in 120 seconds. 416 flips in 120 seconds. Here's technically what you're supposed to do. Technically, you're supposed to divide the top and the bottom by whatever number is here. So technically, you're supposed to do this. And then you get the result. But there's actually one step easier, is you just divide the top by the bottom. So take out your calculator. In this case, you can't really do mental math. And we do 416 divided by 120, and that will tell us how many times it flipped in 1 second. So how many times did it flip in 1 second? Jamel, you already did it on your calculator? What was it? Okay. It says round your answer to the nearest hundredth. So 4 would not be correct. 4 would get marked wrong. Hundredths. Juliana? Just try. Doesn't matter if it's wrong or right. It's close. That's to the nearest tenth. So hundredths is one more over. Okay? So go ahead, Raquel. 3.47. But you rounded correctly, Juliana. You just have to know your places, okay? So that would be 3.47. But here's how you write it. It's 3.47 flips in 1 second. You have seen rates written like this. You could also write it 3.47 flips per second, like that. That's how you would see it in an advertisement, online, something like that. Okay? So that is unit rates. Does anyone have any comments or questions about that? So now here's how we use the unit rates. This is actually true. This is what your families do when they go shopping. Luckily, at this point, the supermarkets do most of the work for us. But let's say that you really love the Honey Nut Cheerios, and so you don't care which box, you don't care, you just want the Honey Nut Cheerios, and that's what you want. So you go to the store with your family, and they got 2 different size boxes. You don't really care, but guess what? Your family probably does. So, I apologize for the interruption. So, what your families do is they actually figure out, and like I said, the supermarket does most of the work for you. But you figure out which one's the better buy by figuring out how much it costs for 1 ounce. That's the whole point of unit rates, is so you can compare. We can't compare because this one's a 12-ounce box and it costs $4.59. This one's a 16-ounce box for $4.89. Now, if all I care about is how much money I have to spend, then you would buy this one. But that might not be the smart choice because you're buying this one for 30 cents less, but you're getting less cereal. And you really like your Honey Nut Cheerios. So you want that box to last a long time. So maybe it makes more sense to buy this box. But maybe it would make more sense to buy 2 of these instead of 1 of these. How would you know? So what we do is we compare. Now here's a little rule about unit rates that you're going to have to remember starting today for the rest of your life. Unit rates, for this question, this came first, that came second. We put that on top, that on the bottom. So that can work most of the time, except when there's money involved. When there's money involved, you always put money on top. So we're going to call this one the small box, and we're going to call this one the large box. And this small box is $4.59 for 12 ounces. And this one is $4.89 for 16 ounces. Which one is the better buy? So we're going to use our calculators and figure out the unit rate. Let's have everyone in teams A through D. You're going to do the small box. Everyone in E through H, you do the large box. Go ahead, it should take you 30 seconds. So, could I have a volunteer from the teams over here on this side? Someone who can tell me how much it comes out for the small box? Go ahead, Kiara.
38 cents.
Well, what was the whole thing? What did it come out to?
Oh, 0.38225.
0.38225. Okay, so it's about 38 cents, but it's 0.3825 per ounce. And what about the large box? I need a volunteer from over here. Caesar? 0.305. Was that it, or were there more decimal places?
625.
625, thank you. Per ounce. And now you compare digit by digit. So which one is the better buy? Which one's the better buy, Paige? The large box is the better buy because you're paying quite a bit less per ounce, because this is really about 31 cents and that's really about 38 cents. So even though it's only 7 cents difference, and 7 cents is really not a big deal, but now you're buying a whole bunch of them, and then, well, you really like Honey Nut Cheerios, you buy it every week. So that 7 cents turns into a bunch of money. So that's something to be aware of. Okay? Good. Any comments or questions? All right, draw one final line across your paper. Your homework is the practice C worksheet. And you're doing 1 through 12 on the front, and you're doing 1 through 4 on the back. Okay. Okay.